Alright, now we go to the inductive step, where we assume that the expression is true for a given value of n, and then we use this inductive hypothesis to perform the induction that the propositional function is true for the next value. Okay, so what does this mean in this context is that we will assume that the 3n is in S. So we will assume this statement to be true, and then we establish the truth of this statement, which basically means that 3 times n plus 1 belongs to the set S also. Okay, so let's see how we can do this. So we assume that 3n is in S by the inductive hypothesis. Alright, so since 3n is in S and 3 is the starting element which is part of S, if we add these two elements, which gives us 3n plus 3, so this element must also be in S, okay, in the set S. Why? Because if we look at the definition of S, it says that if there are two elements in the set X and Y, then their sum is also part of the set, also belongs to the set S. So here we have two elements which are in S, 3n and 3. 3n is in the set because we assume this to be true because of the inductive hypothesis, and 3 is in the set by the definition of the set S, the first part, where we assume that there is an initial element in the set, and this we can express as 3 times n plus 1. So if this 3n plus 3 is in the set S, then this element is the same, so it means that 3 times n plus 1 is also in the set S, which basically implies that Pn plus 1 is true. Okay, so together this basic step and inductive step helps us justify that the set of multiples of 3 is contained in the set S, which was recursively defined.